So here's some help with the lizard joke problem, just to give us more practice on using the log rules. So log base 2 of 6 plus log base 2 of 8. You should take out your little log rule sheet and look to see that if you have the sum of two logs, that you can rewrite that as the log base 2 of the product of 6 times 8, which is the log base 2 of 48. And that's supposed to be a 4. And then look over here to find log base 2 of 48, and it is A. So we know that an A goes here. Always fun to do the riddle. So then the next one is the log base 3 of 10 over 5, because when the log expression has a subtraction in it, you can rewrite it as the log with a quotient. So the base stays the same and you divide the two numbers, and since 10 divided by 5 is 2, the answer shown over here is probably log base 3 of 2. So see if we can find that. There it is. So we use that, and we use that, and so there we go. All right, this one is using the log rule where the coefficient can come up as the exponent. So this will stay log base 1/2, but then it will become 2 to the 4th. So the base is 1/2, and then here's the 2, and then this 4 travels up to the exponent on the 2 and becomes 2 to the 4th. And then that becomes log base 1/2 of 2 to the 4th, which is 16. You could look over here and see if you could find log base 1/2 of 2 to the 4th, but that's not here. But if you simplify to the 2 to the 4th, then you get 16. And so then we know that an I goes here. This next one is very similar to number 2. Even easier, I'd say, because the division of 2 over 3, since we have a subtraction, these divide, 2/3 can't be simplified, and so then that's the answer. So there's number 4. Now I changed this question for 3rd period in 2016 so that we could end up using this rule a little bit. 6th period, you had this question just like this already. So base 3 of the 3 to the log base 3 of 6. If the base here, this base of an exponential expression, is the same as the base of this logarithm expression, there's a nice rule that allows this whole expression to be equal to 6. I think it's so easy that it seems difficult at first, but we are looking at this rule right here. It's on the pink log sheet, and notice that the b and the b here are the same, and so the log function and the exponential functions are inverses of each other, and they undo each other, and then this just becomes x itself. This should have parentheses right there. So this expression is 6, and since this is a 3 and this is a 3, this expression can be rewritten just as 2, and so this becomes it just becomes 6 plus 2, which is 8. And 8 is on here as letter L. And then number 6 is just a little easier because there's only one expression. 2 to the log base 2 of 7 is just 7. So number 6 is Y. And then here we have a little bit more complicated expressions. First, this coefficient has to come up because you can't use the subtraction rule with the logs in it unless if there's a 4 or any other coefficient out here. So first let's bring it up as log of 2 to the 4th minus log of 5. And then since 2 to the 4th is 16, I can say 2 to the 4th is 16, and dividing because of the subtraction, this is 5. So it is the log of 16/5, which is m. And then number 8 has 3 terms in it. Just like when you do addition and subtraction with order of operations, go from left to right. So the first 2 are an addition. So I'm going to rewrite that as log of 6 times 2. And I could leave it just like that, but I'm a little short on space, so I'm going to go ahead and multiply the 6 times the 2 here in this step and say that this is the log of 12, the product of 6 and 2, minus the log of 7. And then this becomes the log of 12 divided by 7, which I think is on here somewhere. Oh, did I cross off the wrong one? No, I already have that crossed off. But log of 12/7. All right, then we've got log base, or 1/2 log 4 plus log 3. So the 1/2 can come up as 4 to the 1/2 power plus the log of 3. Then 4 to the 1/2 power is like the square root of 4. So I can say that that's log of 2 times the log of, or plus the log of 3, which will become the log of 2 times 3, or 6. And the log of 6 is n. And then this one, the 3 can come up on the 2, and the 2 can come up, the coefficient of 2 comes up as an exponent on this 2, and so I get the log of 8 minus the log of 4, which equals the log of 8 divided by 4, which is just 2. So, and then here we just have the subtraction of 2, so we can say that this is the log of 10/4. This is the log of 10/4. And since 10/4 can be simplified, since 2 goes into both of them, I can rewrite it as the log of 5/2. Now you might have stopped and looked to see if log of 10/4 was on there, but since it wasn't, hopefully you had the confidence to look back at 10/4 and realize, well, that's equivalent to 5/2. So there's the E. And then the last one, we have another addition and subtraction problem, but the first thing you need to do is get the coefficient up as an exponent so that you can use the other log rules. Why those 4s don't come out looking like 4s. Here we go. X to the 4th minus log base 5 of y. Now we can take this log base 5 of 3x to the 4th and subtract log base 5 of y, which will become log base 5 of 3x to the 4th over y, which is our last one here, and we get the answer to the silly joke that's so silly I can't even read it. So I hope that helps clear up any confusion from Friday's lesson, and good luck.